Okay, in this video we're going to talk about the connections between f of x and f prime of x, and we're going to be using the derivative to find things like stationary points, relative maximum and minimums, and where f is increasing and decreasing. Okay, in order to do this, there are some rules that we need to know and that you need to memorize. So f of x has a stationary point when f prime of x equals 0. And think about what f prime means. F prime is the derivative, which is slope. So when the slope of my curve is 0, we have a stationary point. F of x is increasing when f prime of x is greater than 0. And I need you to think about that, what that means. F prime of x is greater than 0, which is the same thing as saying when f prime of x is positive. And we should think about that because we're talking about y values. We're going to say positive or above the x-axis. That's what we're looking for. So that's how you need to think about that. F of x is decreasing when f prime of x is less than 0, or when f prime of x is negative, because that's the same thing. Okay? And f prime of x is negative if it's below the x-axis. So for all values where it's below the x-axis, it's negative. Okay, now f of x has a minimum, and in this class we're talking about relative minimums or local minimums, but f of x has a minimum when f prime of x equals 0, and we're going to put in parentheses, or undefined. Okay, and that's important, f prime of x changes from negative to positive. Okay, so it has to, f prime of x has to be 0, which is the one we're going to focus on in this class, but it could also be undefined, and it has to change from negative to positive. So then f of x has a maximum, or a relative maximum in this case, because that's what we're talking about, when, and I forgot to type when, but there you go, when f prime of x equals 0, again, or undefined, and f prime of x changes from positive to negative. Okay, so make sure you have those rules written down, and you have to memorize these rules. You have to know them to be able to do this. And we're going to look at this graphically in class, like what does it look like graphically. But for now, you're just going to use these rules. Okay, let's look at this example. So we're asked to find stationary points, intervals where, and this should really say intervals where f of x is increasing or decreasing, and where it has relative max or mins. Okay, so here's our original curve, f of x equals x squared minus 6x plus 4. So now I'm using this example to show you all of these things, but you may only be asked on a test to find one of them, so you have to know which one you're finding. But we start with all of this, we need a derivative. So we're going to take the derivative of f of x, which is going to be 2x minus 6. And then in order to find stationary points, and really in order to do any of the rest of this, we need to set the derivative equal to 0. So we need to find the x values where the derivative is equal to 0. So we solve for x, so we're going to add 6 to both sides, and we're going to divide by 2. So x equals 3. Now, that is the x coordinate of my stationary point. Sometimes it only asks you for the x coordinates. You have to read the question. But in this case, we just said find the stationary points, which means I need a y value to go with that. So I have my x equals 3. To find a y value, we always go back to f of x, not the derivative. So I can say f of 3 equals, and I can plug 3 in to get my y value that goes with 3. So this is going to be 3 squared is 9 minus 18 plus 4. That's going to be negative 5. So 3 comma negative 5 is my stationary point. So if I was asked to find a stationary point, I'd be done. But in this case, we're not. So from there, we'd have to do this anyway. I would have to find this x equals 3, this x coordinate of my stationary point, even if I wasn't asked to find a stationary point, because we need to use that to find where it's increasing and decreasing, or where there's a max and min. Okay, so we're going to take this 3. We had to have that. We're going to take this 3, and we're going to do a sign chart with it. Now, we know that at 3, my derivative is 0. but I need to test values to the left and right. So I'm going to pick numbers that are close to 3, but that are easy to work with. So like 2 maybe on this side and 4 on this side. And for this part, for our sign chart, we always use the derivative. So if you need to make a note of that, do it. But this is always done with the derivative. So I'm going to say f prime of 2. I'm going to plug 2 into my derivative. And in this case, I'm going to get -2. Now, I don't care about the value. I just care that it's negative. So to the left of 3, my derivative is negative. F prime is less than 0. Then I'm going to find f prime of 4. And of course, you can do all of this math in your calculator. But this is actually going to give me a +2. Again, I don't care about the number. I care that it's positive. Okay, so what this sign chart right here is showing me is that to the left of 3, this way, it's decreasing because my derivative was negative. So my original curve is decreasing. And to the right of 3, because my derivative was positive, my original curve is increasing. So we would say that f of x is decreasing when x is less than 3, because that's to the left of 3. And that f of x is increasing when x is greater than 3. Okay, so now we've found the intervals where it's increasing and decreasing. So now we need to talk about relative maximum minimum. And actually, all we need to do this is this sign chart. So if I look at this 3, it went from negative to positive, and that was a rule that I gave you. If the derivative is 0 at 3, which it is, we've already found that, and it goes from negative to positive, then it's a minimum. But I can also think about what my graph is doing here. So we said that here it was decreasing and then increasing again. So that's what my graph would look like, and so that must be a minimum point. So we can say that there's a minimum at x equals 3. Okay, now if we wanted to know the minimum value at 3 is the y value that went with 3, which was this -5. Most of the time you're just asked for the location of the minimum, which is at x equals 3. But if you were asked for the minimum value, it would be the y value that goes with that, okay? So that's everything we're going to learn. We're just going to do a few more examples. Okay, looking at this one, same thing. We want to find the same pieces of information. I just want to use it to show you how to do that. So we have f of x equals x to the 4th minus 4x cubed. So the first thing we're always going to do, again, is take the derivative. So that's going to be 4x cubed minus 12x squared. And then we always want to set the derivative equal to 0 or find where it's undefined. In this case, we don't have a denominator or square root or anything that's going to give us an issue, so we don't have to worry about that. So if I look at this, I have 4x cubed minus 12x squared equals 0, and I want to solve this, and this is a polynomial, so we usually try to factor those. So I'm going to take out a 4x squared as the greatest common factor, and that's going to leave me with x minus 3. So x equals 0 and x equals 3 are the x values of my stationary points. So I have 2 this time. So I need to find the y values that go with them. So you're finding this y value by plugging back into the f of x. So f of 0 would be 0 to the 4th minus 4 times 0 to the 3rd, which would just be 0. And then for my 3 comma something, I need to find f of 3, which is going to be 3 to the 4th minus 4 times 3 to the 3rd. And that is going to give us -27. So -27 is the y value. So this and this are my stationary points. And again, if I just asked you for stationary points, you would be done. Now we're going to take these stationary points, this is 0 and 3, the x values, just the x values that we found earlier, and we're going to do a sign chart. And when you have multiple values that are going to be in your sign chart, and you could have 2 or 3, we are going to make sure that those are in order from smallest to largest. So I'm going to write the 0 first, and then the 3. And we're going to do a sign chart. 0 and 3 are my important values. I need to test values to the left, between, and to the right of these. Over here, I'm probably going to test -1. I don't always write this on my notes or on the problem that I'm doing because I don't want you to accidentally use this. You've got to make sure when you state your answer, use 0 and 3. But for us, for our notes, I'm testing -1. And then in here, I could test 1 or 2. And over here, I'm going to test 4. Remember that these get plugged back into my derivative. So I can plug it in here, or you could plug it in there, and you have a calculator to do that. When I plug in -1 to this derivative, I'm going to get a negative result. Okay, so you can check that with your calculator, but I will get a negative result. When I plug in a +1, I'm also going to get a negative result. And when I plug in a +4, I'm going to get a positive result. And guys, it's important for you to see this because most of the time we do these sign charts and this might go positive, negative, positive. But there are times when it doesn't switch. And so it's really important for you to see that and to always check your values and not assume that it's going to switch. Okay, so now what we're going to do is we're going to say that f of x is decreasing when... Now, it's decreasing to the left of 3, and it just keeps decreasing. So even though this 0 is a stationary point, so it levels out for a minute, it never changes directions. So this is negative in both places. So we're just going to say that it's decreasing when x is less than 3. I don't need to write both. I can just say less than 3 because it never changed directions. And then f of x is increasing when x is greater than 3 because it's increasing to the right of 3. Okay, so that's our increasing, decreasing intervals. And now we're going to use this sign chart to determine if we have a maximum or minimum. Now, this one doesn't change signs at 0, so that one is neither a maximum or a minimum. But at 3, it changes from decreasing to increasing. So it was decreasing and then increasing. So that has to be a minimum point. So we have a minimum at x equals 3. Now our minimum value, if we were asked for that, is the y value that goes with that 3, which is -27. But you can memorize the rule that when we change signs from negative to positive at a stationary point, that's a minimum. Or you can just kind of know what's happening with your graph. If it's negative, if our derivative is negative, my graph is decreasing and then increasing. And so I know that that was a minimum. Okay? Okay, on this example, we are asked to find the set of values of x for which y equals x squared minus 2x plus 4 is an increasing function. So they're not asking for anything other than where is this increasing. So I want you to take a minute and pause the video and try this problem. Okay, so for this one, we do need a derivative. Now they gave us y, so I'm going to say dy dx equals. When I take the derivative, I get 2x minus 2. Again, we always need to set this derivative equal to 0 and solve for x. And so when I do that, I get x equals 1. Now, if I had been asked for stationary points, I would need to find the y value of that to state my stationary point. But since I wasn't asked for that, I'm only asked for where is this increasing? Where is f, or y in this case, increasing? I don't need to do anything else with that other than go straight to my sign chart. So that x equals 1 is going to be part of my sign chart. Going to test a number to the left, like 0. Remember that you're plugging it into your derivative. If I plug a 0 in there, I get negative. And if I plug in a number to the right of 1, like 2, I'm going to get a positive value. So I can look at this and tell that my original equation, y equals x squared minus 2x plus 4, my curve, is increasing to the right of 1. So we would say y is increasing when x is greater than 1. So right there, when x is greater than 1. And that's the only thing it asked us for. Okay? Okay, again, I want you to pause the video and I want you to try this one. And in this case, we're only asked where is this one decreasing. Take a minute and try it. Okay, so to do this one, again, I need a derivative. We should be pretty good at our derivatives by now. When I take the derivative of y, I'm going to get dy dx equals 3x squared minus 12x plus 9. And then we're going to set that equal to 0 and solve for x. Now, I see that this is a quadratic equal to 0, so I'm going to factor it. I'm going to take out a 3 as a greatest common factor. And then when I factor further, I'm going to get x minus 3 and x minus 1. And so x equals 3 and x equals 1 are my x coordinates of my stationary points. Again, we weren't asked for stationary points, so I don't have to find the y values, but these are the x values of the stationary points. But to find where this equation is decreasing, I need to do a sign chart with these, and I need to make sure that I write them from smallest to largest. So I'm going to put the 1 first and then the 3. And I'm going to test values to the left, between, and to the right. And I'm going to plug them into one of my derivatives. So either here or here, it doesn't matter. When I plug in something to the left of 1 like 0, I'm going to get a positive value. If I plug in a 2 here, I'm going to get a negative value, and you can check this with your calculator, okay? And if I plug in a 4, I'm going to get a positive value. So now we can see that it's decreasing between those two numbers. So we're going to say this is decreasing when x is between 1 and 3. And that's how we write it. It's between 1 and 3, so we write it between 1 and 3. So 1 is less than x, which is less than 3. That's how we're going to write our answer. Okay? Okay, on this one it asks us to find the stationary points of the following curve and determine their nature. And determine their nature just means, do I have a max or a min at that stationary point? So that's just a wording to get used to. So I want you to take a minute and pause the video, find the stationary points, and then determine if they're relative max or relative mins. Okay, so again, we need a derivative. The derivative of this is going to be 2x minus 4. We need to set the derivative equal to 0 and solve for x. So when I do that, I get x equals 2. That's the x coordinate of my stationary point. But I need the y value. So I need 2 comma what y value. And I go back to this y equals x squared minus 4x plus 5, to my curve. I go back to my curve for that. So if I plug in 2 to that equation, I get 4 minus 8 plus 5. So I'm going to get 1. So 2 comma 1, this is my stationary point. Now I just need to determine if it's a max or a min. To do that, we use a sign chart. So I'm going to take this x equals 2, and I'm going to do a sign chart. So I'm going to test a number to the left and a number to the right. But remember when you do that, you have to use the derivative. So here we are. When I plug in a 1, I get a negative value. And when I plug in a 3 onto the right of 2, I get a positive value. So since this changes from negative to positive, it would be decreasing and then increasing. So this has to be a minimum. So we have a minimum at, in this case, our stationary point. They said find the stationary points and determine their nature. So it's technically a minimum at 2, and the minimum value is 1, but we can say we have a minimum at that. That's the coordinate of my minimum, so that's okay as well. You could also say you have a minimum at 2, x equals 2. Okay, last example. I want you to take a minute, pause the video, and try this one. Okay, again, I need a derivative. So dy dx equals 12 minus 4x. We set our derivative equal to 0 to solve for x. And we get that x equals 3. Again, it asked me for stationary points. It didn't just say find the x value of the stationary point. So I have to find the y value that goes with that. And to do that, you plug it back in here. So you're going to have y equals 12 times 3 minus 2 times 3 squared. This is going to be 36 minus 3 squared is 9 times 2 is 18. So we're going to come out with 18. So 3 comma 18. Okay, so our stationary point is this. And now we need to determine at that point if we have a maximum or a minimum. Okay, so we do a sign chart. We take our x value and we test values to the left and right. So to the left of 3, we have 2. If I plug 2 in my derivative, I get a positive. And if I plug in a 4, I would get a negative. And so this graph, this original graph here, we're using our derivative to tell us about this graph, but I would be increasing until I got to 3, and then I would start decreasing. So this is a maximum. So we have a maximum at x equals 3. And the maximum value is 18. So you could just write your coordinate and you could state that that's a maximum, or you could say maximum x equals 3 of 18. Either way, okay? All right, go back and review what you need to review, and I will see you in class.